Hi everyone again, and welcome back to a new episode of the Altitude Collection Infographics video series. Today I'm gonna be sharing with you guys the results concerning the cerebrovascular and cardiorespiratory variables that were assessed among the lowlanders and the ascent Sherpa. As a reminder, those groups did together the trekking from Kathmandu at 1400 meters all the way to the Pyramid Research Laboratory at Everest Base Camp. I will mention that, or I will call it just as the laboratory or the pyramid. Okay, so they were assessed, or the assessments were carried out in Kathmandu at 1400 meters, in Namache at 3400 meters, in Periche at almost 4400 meters, and at the laboratory or pyramid at 5050 meters. Also, when I mention the term flow and velocity, what's the difference between flow and velocity? The flow of a vessel is the volume of blood that is circulating in a certain vessel. In this case, there were assessment into vessels. In the vertebral artery, which irrigates the supratentorial posterior cerebral region, or basically the posterior cerebral region and the deeper one, okay, and the internal carotid artery, which irrigates basically the middle and the frontal supratentorial posterior region, and the velocity. Velocity is the speed, okay, or velocity of a fluid inside the vessel, which is expressed as centimeters by seconds or per second. Another interesting concept that you might understand, and I'm gonna remind this, but that was mentioned in the previous episode, is the cerebrovascular conductance. When we talk about cerebrovascular conductance, we refer to changes in the global cerebral blood flow, which is estimated as 2 times, as there are two cerebral hemispheres, the sum of the vertebral artery flow plus the internal carotid artery flow. So, cerebrovascular conductance is the change of the global cerebral blood flow per a unit change of the mean arterial pressure. So this is the reason for what this is expressed as milliliters per minute per millimeters of mercury. Milliliters per minute per millimeters of mercury. So I also will mention in this episode the results that were obtained after arriving to the pyramid laboratory. All the groups studied in this research. The 2 previously mentioned, lowlanders and the ascent Sherpa, those who did the trekking from low altitude Kathmandu to the pyramid research, and those who were called as the altitude Sherpa, which only moved from their resident towns at around 4,000 meters to the pyramid laboratory. Basically, the difference in altitude were only like 1,000 meter elevation. So I will also will discuss about the result obtained between these three groups in the Pyramid Research Laboratory. So first of all, I'm going to be reading the results presented in table 3 of the article, which is concerning the influence of ascent to altitude on cerebrovascular variables, which means basically the influence that the progressive winning in terrestrial elevation has on the different cerebrovascular variables that were assessed. And I'm going to be reading this because I think I'm going to generate less confusion in the audience, because the results of the results are massive. I mean, there are a huge amount of data presented in the results section. So I think this is going to be a more efficient way for in order to help you to comprehend the exposition of the different results. So first of all, regarding the velocity of the internal carotid artery, there were differences between the groups. At 3400 meter, the ascent Sherpa ICA, or internal carotid artery velocity, was significantly lower compared to the lowlander value. Also, comparing the result with an individual comparison, okay, of different altitude with the value observed or reported in Kathmandu, I gotta mention that at the Pyramid Research Laboratory, the lowlander value was significantly bigger compared to their value at Kathmandu. Okay, another variable, which is the diameter of the ICA, there were no differences at any altitude assessment point between groups, no differences between Sherpas and lowlanders, but lowlanders reported lower values at 3400 meter and at 4400 meter compared to the results reported in Kathmandu. And same happened with the Sherpas. At these points, their values were significantly lower compared to the one observed at low altitude in Kathmandu. It is interesting because in this trekking, this is out of the paper discussion, if we base our discussion in the classification of the altitude or terrestrial elevation, which was published in, I think, 2007 by Barge and Saltin and Borak. In this research, we have the three different levels of terrestrial elevation: low altitude in Kathmandu, 1400 meter, moderate altitude in Namanche, 3400 meter, or high altitude, more than moderate, because high altitude is from 3000 meter. High altitude as well in Periche, 4400 meter, and the higher, let's say, threshold of the high altitude elevation, 5050 meters, which is near to the already extreme altitude level, based on this classification, which starts at 5,500 meter. So when I discuss this, you gotta think about the differences or the oscillations from different variables according to the level of the magnitude of terrestrial elevation. So, in the ICA flow, just a reminder, milliliters per minute, there were no differences between groups, but at 3400 meter, both groups showed lower results compared to the value reported in Kathmandu, or the flow was lower compared to the flow at Kathmandu. And then at the pyramid, there was an oscillation. So Kathmandu going down the flow at 3400 meter and then raised to a higher level compared to Kathmandu. In the Pyramid Research Laboratory, the values of both groups were significantly higher than the one reported in Kathmandu at 1400 meters. Regarding the ICA oxygen delivery, or the oxygen delivery to the brain through this vessel, in Namanche, the Sherpa groups have a lower oxygen delivery through this vessel compared to the lowlanders. At this point in Namanche, at 3400 meters, the Sherpa has a lower cerebral oxygen delivery compared to their results obtained by this group in Kathmandu. And in Periche, at 4400 meters, the lowlander had a lower oxygen delivery through the ICA compared to their value at Kathmandu. It's interesting how there is not a uniform response, increasing, decreasing, increasing in one group, decreasing. No, it can be changed. That's the difficulty for discussing all these results. Okay, so now let's gonna see what happened with the vertebral artery, different variables from the vertebral artery. So regarding the velocity, there were no differences at any time point between group, but there was a significant higher velocity, flow velocity, okay, in the Pyramid Research Laboratory in the lowlander group compared to their value at Kathmandu. Then about the diameter, how did it change? Did it increase? That was narrower, that was wider. Okay, so there were differences at all altitude assessment points between groups. Sherpa has a lower vertebral artery diameter compared to lowlanders in Kathmandu, in Namanche, in Periche, and in the Pyramid Research Laboratory. In fact, this is the result which triggered or highlighted the most striking finding of this research, and that will be exposed in the conclusion section in a few chapters, I think. And then also the Sherpas has a lower diameter at Namanche compared to Kathmandu, but not in the other assessment scenarios. Regarding the flow of the vertebral artery, there were no differences between groups, and only there was significant difference reported in this table regarding this variable, and was the significant increase, and I will give you the percentage of change afterwards, from the lowlanders at the Pyramid Research Laboratory, significant higher value compared to Kathmandu. Regarding the oxygen delivery through the vertebral artery, there were no differences between groups, and there were no differences If we do an intra-individual group comparison, comparing values reported at 3,400 meter, 4,400 meter, and the research laboratory compared to Kathmandu at 1,400 meter. And regarding the mean arterial pressure, yes, there were differences between groups, and that will be discussed in the highlighting striking findings from this research in the conclusion section. Sherpa has had higher mean arterial pressure values in Kathmandu, in Namache and in Periche compared to the lowlanders. Then imagine how much is gonna be decreased from Namache to the pyramid, that both groups in the pyramid have the same levels, the same value, no differences in this variable, okay? And then lowlanders had significant higher values in Namache, Periche, and the pyramid. It's like a greater sympathetic autonomic nervous response or cascade in the lowlanders, because right at the end the values are being equal, as they are ascending, the values, the sympathetic nervous response or cascade is bigger among the lowlanders. At these time points, Namache, Periche, and the pyramid research, their values, the lowlanders' values, were significantly greater compared to the one observed in Kathmandu. So, instead of reading a table now, I'm gonna be explaining the results, comparing the results obtained in the Sherpa, in the ascent Sherpa, and the lowlanders of the different variables, cerebrovascular and cardiorespiratory variables, but comparing the magnitude of change expressed in a percentage change of the different variables compared to Kathmandu. So, in lowlanders, the global cerebral blood flow was not or wasn't changed from Kathmandu to Namache at 3,400 meter and to Periche at 4,400 meter. But what happened at 5,050 meter? That variable increased, and I'm going to give you the result in 23.3 with a standard deviation of 26.1%. The flow through the internal artery and vertebral artery followed a similar pattern. I mean, it is simple. Was unaltered or were unaltered at 3,400 meter or 4,400 meter, but the flow of the ICA was elevated by 18.4 and a standard deviation of 26.2%, and the flow in the vertebral artery was elevated by 24.6 with a standard deviation of 31.9% at 5,050 meters. In the Sherpa, what happened in this variable, what was observed in these variables? The global cerebral blood flow was lower at 3,400 meters, this was unchanged in the lowlanders, while in the Sherpa was lower, 21.3, I don't know if you say minus 24.0%, that's something new for me, was lower at 3,400 meters compared to Kathmandu. Then at 4,400 meters, equally the results from Kathmandu, both results were the same. And at 5,050 meters in the research laboratory was elevated by 13.5 with a standard deviation of 22.3%. Now let's gonna see what was observed in the regional flow of the ICA and the vertebral artery. So the ICA flow in the Sherpa was reduced by 22.8 with a standard deviation of 21.6% at 3,400 meters compared to Kathmandu. Then in Periche at 4,400 meters, returning to the Kathmandu values, and was elevated at 5,050 meters by 10%, minus 22.8% at the research laboratory. The vertebral artery flow did not change at 3,400 meters compared to the 1,400 meters of Kathmandu. And at 4,400 meters, the vertebral artery flow was significantly elevated by 10.6% with a standard deviation of 51.2% compared to Kathmandu. It was also further elevated at the Pyramid Research Laboratory and the value that further increase reached the 21% with a standard deviation of 31.8% compared to Kathmandu. Interestingly, and this is one of the results which is considered as an striking finding in this research, there was a significant manifest of race with ICA flow, vertebral artery flow, and global cerebral blood flow, which was greater in lowlanders compared to Sherpa across all the altitude at the different elevations. That means that with this winning in altitude elevation, the lowlanders will need a greater increase of the ICA flow, vertebral artery flow, and global cerebral blood flow compared to the Sherpas. Another interesting observation, and I have been sharing this at the altitude collection infographics, is in the Andeans compared with lowlanders. In this research, there was observed a lower posterior distribution of cerebral blood flow through the, in this case, through the vertebral artery than lowlanders, or compared to lowlanders at all altitude during the ascent. What does it mean? This means that the flow redistribution, or distribution, it is more predominant in the Sherpas in the middle and anterior supratentorial cerebral region compared to the lower distribution of blood flow in the posterior cerebral region. So it is interesting how there is a balance in the homeostasis, or there is an homeostasis on the global cerebral blood flow, but the flow distribution is more predominant on the middle and anterior cerebral region compared to the posterior cerebral region. This is another highlighting, striking observation. The global oxygen delivery was maintained in the lowlanders during the ascent from Kathmandu to the Pyramid Research Laboratory. But in the Sherpa, this variable, okay, which is linked to a return mechanism in terms of dynamic cerebrovascular dynamics to maintain or sustain the oxygen fluid to the different cerebral structures in the brain, in the hypoxic environment. Okay, in the Sherpa, this variable was reduced at 3400 meters by a 30.3% with a standard deviation of 21.6%. At 4400 meters was reduced by a 14%, but this is interesting, the oscillation I was explaining to you, or trying to explain to you, what mechanisms are differing, okay, from 4400 meters all the way to the 5000 meter altitude in the Sherpa, that at Kathmandu there were no differences in the global oxygen or cerebral oxygen delivery. There were no differences in the research laboratory compared to Kathmandu. For me, this is something really astonishing, an astonishing result. And I know that we have to treat that in a more objective way, but for me it's astonishing. Okay? Compared to lowlanders, the Sherpa has lower oxygen cerebral delivery at 3400 meters, at 4400 meters, and at 5050 meters. I mean, it's weak, and this will be also discussed in the conclusions of the article. It's an advantage. It seems to be an advantage, and in terms of a pathophysiology of the altitude, and or human pathophysiology, and I will discuss right at the end of the article. In terms of this variable, the cerebrovascular conductance, which is, as I was probably mentioning, the how much does the global cerebral blood flow change per change in a unit of mean arterial pressure, in this case a millimeter of mercury in the mean arterial pressure. Lowlanders, Sherpa, and has a reduced cerebrovascular conductance at 3400 meters compared to Kathmandu. There were no differences at 4300 meters compared to Kathmandu, and there were no differences at 5050 meters compared to Kathmandu. And interestingly, there differences between groups in these variables. But when I explain now the comparisons of several variables at 5,000 meters between the altitude Sherpa, the ascent Sherpa, and the lowlanders, there will be a difference in the mean arterial pressure, and the altitude Sherpa will or reported a lower mean arterial pressure compared to the lowlanders. Not with the ascent Sherpa, but yes with the lowlanders. Isn't it interesting? So, just to finish with this presentation, which is it's been longer than I was expecting. I'm gonna show you the results presented in the table 4 of the article, which compares different variables which were assessed at the Pyramid Research Laboratory between all of the groups studied in this research, the lowlanders, ascent Sherpa, and the altitude Sherpa. So I'm going to start with the arterial oxygen content. There were no differences between groups in this variable. But, for instance, the hematocrit and the hemoglobin concentration, and also the oxygen saturation, was higher in the polyphthalmic variables. In the hemoglobin and the hematocrit was higher in the altitude Sherpa compared to both the ascent Sherpa and the lowlanders. And for that reason, of course, the oxygen saturation was higher in the altitude Sherpa compared to the, or relative to the other two groups. In fact, the difference was really like a dramatical difference. 86.73 with a standard deviation of 3.42% in the altitude Sherpa, with almost, let's say, 77-78% with a standard deviation of 5-6% in both the lowlander and the ascent Sherpa. So now it's time to discuss the arterial pressure gases. The arterial pressure of the oxygen was not different between groups, and the arterial pressure of the carbon dioxide was higher in the ascent Sherpa compared to the lowlanders. So there were a bigger respiratory alkalosis in this group. Regarding the pH, the most basic pH was found in the lowlander, which was significant higher compared to the ascent Sherpa and compared to the altitude Sherpa, but the altitude Sherpa pH was the most acid because it was significant lower compared to the ascent Sherpa. No differences were observed in the ion bicarbonate between groups, but regarding the basis excess extracellular fluid, it was significant lower in the ascent and in the altitude Sherpa compared to the lowlanders. There were no differences in this variable compared to the between both Sherpa groups. Regarding the mean arterial pressure, and as I mentioned it previously, the altitude Sherpa had significant lower mean arterial pressure compared to the ascent Sherpa and to the lowlanders. There were no differences between both Sherpa groups, but and also because it's connected, and I have mentioned it previously, the cerebrovascular conductance values, there were no significant differences between any groups, and it has I mean, that was expected, as there were no differences in the mean arterial pressure. And just as a reminder again, because the difficulty of the comprehension of the different variables, the cerebrovascular conductance is calculated as the quotient, global cerebral blood flow quotient, regarding the mean arterial pressure, or the change in global cerebral blood flow per unit of millimeter mercury in the mean arterial pressure. Sorry, right at the end I was a little bit tired after a long time trying to explain you all these different results reported in the article. I hope you have liked this new episode, and as I mentioned in the previous episode, I will discuss the covariate analysis in the next chapter. I think this will be a really or much shorter, so I will give you a few days in order you just can digest all the massive results that I have given you in this session, and I promise you a much shorter, but I don't know if more interesting session in the upcoming episode. Hope you are fine. Take care, my fellas, and see you soon.